In this video we're going to look at some more percent problems. In these particular problems we are going to have to find the whole when we're given the part and the percent. And we're going to do that by using these formulas, actually by using the bottom formula right here. If you've watched any of the other videos, you've seen that we started off with this main formula right here, the whole times the percent equals the part. The other two versions of this formula are just derived from the original version of the formula. There are different ways to do that same formula. So we know the whole times the percent equals the part. Therefore the part divided by the whole would give you the percent, and the part divided by the percent would give you the whole. An easy way to see this is if you just plug in numbers. This might seem a little confusing with the formulas, but if I told you, which you already know, that 5 times 2 is 10, you know that's true. 5 times 2 is 10. Well, that also means that 10 divided by 2 is 5, and 10 divided by 5 is 2. When you know two things multiply together to give an answer, you know you could take that answer and divide it by one of the things that multiplied together to give it, and you'd get the other one. And that's exactly what's happening over here. We know the whole times the percent is the part. So the part is like where the 10 is. The part is the answer of a multiplication problem. So therefore, you could take the part divided by the whole, and you'd end up with the percent. The part divided by the whole would give you the percent, or the part divided by the percent would give you the whole. It's just like what's happening over here. This is like what's in the whole spot, this is what's in the percent spot, and this is what's in the part spot. So the part is the answer. If we divide it by either of these two things, we'll come up with the other one. If you're comfortable with just memorizing the formula in the box and coming up with the other two formulas, you could do it that way. Or if you're not real sure, you could just memorize these three different versions of the same formula. Let's look at our first example. 18 is 30% of what number? In these type of problems, the first thing you want to do is identify what is the whole, what is the percent, what is the part, or what am I missing? You're going to be missing one of those three things. We certainly can tell which one is the percent because it has a percent sign after it. So we know the percent in this example. And the question says 18 is 30% of what number? This is what we're trying to find. What number? We don't know that. We know the 18. So this, what we're trying to find, this what number, is that the whole or is that the part? 18 is 30% of something. Well, that is the whole. Okay, 18 is a certain part of some big whole number. So we've got some big amount, and we got 30% of that whole amount comes out to be 18. So in this case, we're trying to find the whole. And we know by this formula, the part divided by the percent equals the whole. 18 is the part and 30 is the percent. So in order to figure out the whole, I need to do 18 divided by 30%, and that's going to give me the whole. Now up here in the formulas, I'm using like a fraction bar or a slash for divide. It's the same thing as the division symbol. Anytime you're working with these type of problems, you need to change your percent into a decimal. So 30% in a decimal, move your decimal twice, is going to be 0.3. That's all we need to do to come up with our answer. So now the question is, do you have access to a calculator or not? Are you allowed to use a calculator on what you're doing? So let's do it without a calculator first. 18 divided by 0.3. So we want to set that up. 18 divided by 0.3. Now whenever you have a decimal outside your division sign, you want to get rid of that. You don't want to divide by 0.3, you just want to divide by 3. So we have to move this decimal to the end of the number, so we just have a 3. Now if we do that on the number outside, we have to do that on the number inside. So we have to move that over 1, and then we'll put a 0 there. So now we're looking at 3 into 180. And that should be pretty straightforward. 3 goes into 18 6 times, with 0 left over, but we still need to account for this 0, and 3 goes into 0 0 times, so the answer is 60. Let's see if that answer makes sense. If we put it back up in here and into the original statement. 18 is 30% of 60. Does that make sense? If I took 30% of 60, if I had $60 in this pot, and I took 30% of it, well, 30% would not quite be a third, right? If I took 30% and 30% and another 30%, that would only be 90% of the whole thing. So 30% is close to a third. If I took 60 and divided it by 3, I would get 20. But 30% isn't quite that. So 18 is 30% of 60. That makes sense. It's a logical answer. I'm thinking about ways that you can look at your answers and decide if they make sense by estimating. You always, always, always want to do that in any kind of math problem. Just look at your answer and ask yourself, does it make sense? Maybe put a real life scenario on it. Let's say something was 30% off. So if you took 30% of 60, say it was originally $60, would it make sense that you would save $18? That would make sense. That seems like it's pretty much in the ballpark. All right, let's look at another example. We'll get rid of this stuff. Okay, this one has a little different issue with it. 23.5% of what number is 160? So we know that the percent is 23.5%. Of what number? So we're taking 23.5% of some number. That number right there is going to be the whole. Another way you can look at this is the word of in these kind of problems means multiplication. So we have 23.5% times some number equals some number, and that fits this pattern in the original equation, that the whole times the percent equals the part. Whatever your percent is being multiplied by, it's going to be the whole. So here you're taking 23.5% times what you don't know, so that's the whole, and it's supposed to come out to be 160, which is the part. Alright, so we're going to take the part divided by the percent to equal the whole. So we need to figure out what is 160 divided by 23.5%. Okay, well, we have a fraction in our percent, and what we want to do with that is first turn it to a decimal. A lot of times when you see these fractions in percents, they're going to be fractions that are common decimals. They have common decimal values. So what is the decimal for 1/2? Hopefully you know that that's 0.5. So you want to change that to 0.5. Then you need to move your decimal over 2 places to change it to a pure decimal number without the percent sign in it. So now we have 160 divided by 0.235. Let's pull up the calculator for this one. So we're going to punch in 160 divided by 0.235 equals. Alright, we get this big old long number. So what we would want to do at this point is check the directions and see if it said to round it to a certain place value, like tenths or hundredths. If it was a story problem that involved people, say this was 160 people, then this 680 would be people, so we would probably round it to the nearest person, which would be 681. If it represented money, we'd want to go to the nearest penny, so it would be $680.85. You need to look at the context of the problem or the directions. For our purposes, let's just round it to the nearest tenth. So we would want to go 680.85. This 5 would round that 8 up to a 9. So let's do 680.9 as an estimate. Let's look at a story problem, a real life kind of problem where you would see this kind of situation. I was just listening to a basketball game and they were talking about the percentages made and of their shots. In a recent basketball game, a team made 45% of their shots and they made 27 baskets. How many shots did they take? So we're looking for the whole number of shots that they took. And we know that the part of the shots that they took in which they made was 27 baskets. Let me say that one more time, maybe a little bit better. They took a total number of shots we don't know. A certain percentage of those went in the basket, which was 27. So that is the part that they made, the 27. If you think you know how to do this, go ahead and pause it, try it, and start the video when you're done. Alright, so here we have the part. The 27 is the part that they made. It's not the whole number of shots they took, it's the part that they made. And obviously this 45 is your percent. So we don't know the whole. In order to find the whole, we do the part divided by the percent. So we're going to do 27 divided by 45%. We need to move our decimal over, so that's going to be 0.45. And for the sake of time, we'll punch that into the calculator. 27 divided by 0.45 equals 60 shots. Alright, does this answer make sense? That's what we want to ask ourselves whenever we get an answer. So we're saying they took 60 shots and they made 45% of those, which is a little less than half. 50% would be half, which would be 30. They made a little less than that, and it says they made 27. That's a little less than 30, so my answer makes sense. I'm happy with that. So they took 60 shots. That's my answer. Alright, let's look at a couple more examples. Next one. Tom saved $12 on a sweater that was on sale for 20% off. What was the original price of the shirt? Again, if you think you know how to do it, pause the video, give it a try, and then start it up and see how you did. Alright, so we know he saved 20%, so that's your percent. The $12 is the part of the original price that he saved. The original price is the whole price. We don't know that. So again, we're going to follow our formula, and we're going to take the part divided by the percent, and that will give us the whole. So 12 divided by 0.2. This seems like a pretty straightforward problem to do without the calculator, so let's try that. 12 divided by 0.2. 12 divided by 0.2. What are we going to do with that decimal there on the outside? We're going to move it over 1, which is going to move this over 1. 2 into 120. Well, 2 goes into 12 6 times, and then we have the 0. So the answer is 60 bucks. Does that make sense? A $60 sweater at 20% off, would that save me $12? Yep, it would. Now, if you watch my video on estimating it all, we know that in order to find 10% of a number, all you have to do is move the decimal over once. So 10% of 60 would just be 6. Therefore, 20% of 60 would be twice as much, which would be 12. And that matches our situation. 20% off, he saved $12. That all works. Alright, last one. It's always good to try a bunch of examples. In the Dalton School District, 23 teachers will retire in the next 3 years, which is approximately 8.2% of the total number of teachers in the district. How many teachers work in the Dalton School District? Again, if you know how to do it, think you know. Even if you don't think you know, maybe pause it and just try it on your own and see what happens. Alright, so we have our percent of the teachers that are going to retire, which is right here. We know the part of the total number of teachers that's going to retire, which is right here. And we're trying to find the total number of teachers that work in the district. We're trying to find the whole. So we're going to take the part divided by the percent. 23 divided by 8.2%. Move that decimal over twice. Now when I move this decimal over twice, I'm going to have to put a 0 in there to take that place. So I end up with 23 divided by 0.082. And I've mentioned in other videos, but not this one yet, that I always put this 0 right here to the left of the decimal, really to just accentuate the fact that there is a decimal here. But this decimal is not, or this 0 is not necessary. You could just write 0.082. Again, I don't want this little decimal to get lost as a speck. So if I put the 0 there, it really says, hey, there's a decimal here. Alright, so let's use a calculator on this one. 23 divided by 0.082 equals, again, big long decimal here. So let's look at the context of the problem. What are we looking for? We're looking for how many teachers work in the school district. Now this 8.2% was an approximation. Maybe it was actually, 8.2567, I don't know, some big percent. But they just rounded to the nearest tenth. So we need to round our answer to the nearest person because this answer, this 280, is representing people. So we want to round it to the nearest person or whole number. We have a 4 right after the decimal in the tenth spot. That's not enough to round up to 281. Remember, if it's 4 or less, you're going to just keep the same number. If it's 5 or greater, you're going to round it up. So let me write this out so I can talk about that just a little bit more. 280.487. Let me just write the first few digits of that. 280.487. So if I'm going to round to the nearest whole number, I'm really going to look at just the digit right after the whole number. I don't even care about this stuff. I'm just looking at the 4. And I'm asking myself, will that 4 round that 0 up to a 1? And since it's not 5 or bigger, it will not round it up, and I'm going to keep it at 280. So approximately 280 teachers in the whole district. Does this make sense? Well, if I had 280 teachers and 8.2% of them were retiring, would that be about 23 teachers? Let's think about what we just talked about with the 10%. 10% would be a good estimate of 8.2%. It's going to be close. What would 10% of 280 be? Remember, when you do 10%, you just move that decimal over. So if it was 10% of 280, it'd be 28 teachers. But it's a little less than 10%. It's 8.2%, which is less than 28 teachers, about 23 teachers. This answer makes sense, and you always want to see if your answer makes sense. Use your common sense along with your formulas and all the other math techniques that you know.